Greetings and welcome. Wow, you've joined us here. We're going over page 53, Su tarea de anoche, perhaps, or esta noche if you're doing it right now as you watch this video live, maybe. That's fine. So problem 21, it's asking us to write a absolute value inequality that represents this solution set. If you guys can't see it, it's open circle at 3, -3, and shaded in between. So first of all, before we do that, could you guys even write a compound inequality that represents that?
I said -3 was less than x, and that's less than 3.
Sure, I like it. So the way we could describe the absolute value situation, though, is, let's see, the absolute value of x is in between 3 and -3, right? And remember, absolute value represents distance. So I want all points whose distance is within 3 units away from 0, right? Because absolute value represents the distance from 0. So think about it this way, as that represents the all points within 3 units from 0. Is kind of how we could understand that. So, right, so within 3 units, so that's why it's a less than sign. If it was shaded away, I could actually make this a greater than sign, and it would be, the wording would be all points beyond 3 units from 0. So further than 3 units, right? So that's kind of how you could comprehend that a little bit. Those take a little bit of practice to get used to and stuff. I think the general breakdown is that you kind of have to figure out where the center is, the midpoint, and I could call that C, and then you could call this distance, I don't know, I'm just making up letters now, A. And the general format is the absolute value of x, I think it's minus C, and in this case shaded in between would be less than A. Right? Something like that would be your general rule of thumb. So if I had the same thing, but shifted over 1, let's say I've got it 0, and then, but it goes between -2 and +4, right? So it's the same spacing. Actually, is that a good one? Yeah, that's still 6 units apart. Where would the midpoint of that be? 1, okay. So here's the midpoint, and then it's 3 units, right? 3 units both directions, and the midpoint is 1. So I think the answer to this would be the absolute value of x minus 1 is within 3 units. So I'd be interested in all points within 3 units of 1. And the opposite part there is a little bit weird. Let's verify that this works. Is, let's see, would -1.5 work? -1.5 minus 1 is negative, wait, sorry. Yeah, is -2.5. The absolute value that makes it positive. Is 2.5 less than 3? Yes. Let's try 2.5, or 3.5 actually, better yet. 3.5 minus 1 is 2.5. Absolute value of that is 2.5, which is less than 3. So it seems like I have accurately represented it. So yeah, so that's kind of a general approach that you could do that. Let's see, 37 is the more typical problems that we were dealing with yesterday, where I've got an absolute value inequality. The first step is get the absolute value by itself, which this is done. The absolute value is isolated. Next step, break it up. Break it up. So either 3x plus 11 is greater than 1, or what's the other case?
3x plus 11 is less than -1.
Right, so 2 things happened there. I flipped the sign or I flipped the inequality and changed the sign. Right? So some of us forgot to do one or both of those things when we were doing our gallery walk yesterday. So let's see, subtract 11 from everybody now. 3x is greater than, let's see, that looks like -10, because 11 was more influential. 3x is less than -12, because those guys formed a gang and became more negative. Divide by 3, div 3, div 3. And I get, let's see, x is greater than negative 10/3. So make sure you guys are writing down your corrections if you've got any of these problems wrong, and this would be -4. Oh, actually, time out. Let's not box those yet. I was jumping the gun. Let's figure out what is this representing. So negative 10/3, let's see, what's that? Negative 3 1/3 if you wanted to write it that way. Let's graph this and figure out what is going on here on the G Rafe. So here's 0, 1, 2, 3. Here's -3, and here's -4. And then let's see, I'm working with thirds here, so let's divvy up my tick marks into thirds. So let's see, what's this first one tell us to do? -3 1/3. What kind of circle?
Open.
Open. Shaded which way?
To the right.
To the right. Right, okay. Yep, correct, as they might say. X is less than -4, what do I do?
Go to -4.
Yep. Okay, so these are shaded away from each other, which is the easier one to... Shaded away because it's or. And the reason it's or is because any of my solutions are true for either one of those at a time, but never both. Right? For instance, 0 is greater than -3 1/3, but it is not less than -4. So the solutions here are going to be true for one or the other, never both. Whereas for AND problems, they are true for both simultaneously. Okay, check this out. This one I actually really like, if I remember. I knew that this one was going to come up last night, and I smiled. So here we go. I'm going to solve each of these independently. So I'll get x is greater than or equal to, oh, that's an ugly greater than sign, -7. And over here I'll have add 2 to both sides, right? +2 +2. And I'll get x is less than or equal to 6, right? But the logic that was forced upon us was OR. Oh, let's see. OR. So let's graph this and see what happens. So let's see. 0, 6, -7's a little further away. So let's see. What does this one tell me? Closed circle and right. Right? Okay. Well, actually, I'll just draw a piece of that for now. And then what do I got? Closed circle and left. Now, what I want to point out is this is an OR problem, okay? Because they kind of made it that for the get-go. So watch this. This arrow is 0 less than 6? Yes. Is -7 less than 6? Yes. Is -8 less than 6? Yeah. And is 0 bigger than -7?
Yes.
Is 6 bigger than -7?
Yes.
Is 10 bigger than -7?
Yes.
Yes. So it turns out because of the OR, this point here is true for this, but not that, and that's fine. That passes, that's a successful point for us. This point here, +10, is true for this, but not that, but because of the OR logic, that's a successful point for us. So it turns out our shaded region looks like this. It's just everything. So one of the ways you could write that is, you might have seen the book using this notation, the set of all x such that x or something like that. Like there's no limitation on x, it's just everything. Or they might have written like all real numbers.
Yeah, so all reals.
All reals. Later we'll talk about the non-real numbers, the imaginary ones. They're pretty good. Don't worry about them. But yeah, so this one's particularly tricky only because of the OR logic there. If you got this far, you understand the concept of solving it, but taking that answer and translating it to this is where kind of the nuance is right there. And yeah, so that's kind of that. I knew that was going to show up, but I didn't feel like explaining it in the lesson yesterday. So that's 3 problems. 1, 2, 3. I think we're good. Happy day. Happy day. So have a good day, everybody. Looks like 10 minutes.